Today we are starting key concept 3, which is systems of equations and inequalities. So in KC2 you guys learn about equations and inequalities, and we were just talking about one equation and one inequality. Well, systems of equations just means more than one equation. All right, so systems has more than one equation. So you're going to be using, give me a second, more than one equation. That uses the same variables. All right. Another thing that we are also going to be talking about in KC3, and I'll repeat it, remind you guys once we get to that target, but we are going to be talking about the slope-intercept form. Okay, which again is y equals mx plus b, which is the one equation we kept talking about throughout KC1 and KC2. M is the slope, B is the y-intercept, Y is the total, X is the input, and obviously Y, since it's the total, it's the output. You also going to be talking about the standard form. And a standard form is also the slope-intercept form, but it is written as 8x plus by equals c. Again, it's the same equation as the slope-intercept form. I'm just rewriting it. So, okay, I can say that it's actually mx plus y equals b. The constant number is at the right side. The letters x and y, so the input and the output, have to be on the same side. So that's what standard form is. Okay, so you're going to be also talking about both of those. And again, we'll talk about more of those eventually in target B. As of right now, we are starting target A, which again is the introduction to systems. And what we're going to be learning about in this target is how to write those equations based on real world situations. So real life situations, okay? So once again, keep in mind that we're going to be writing two equations with the same variable. The most important thing is that we need to identify that variable. So we're going to use the variable x. What does it represent? So you need to let me know what it represents, okay? So here we go. It says, the Morton soccer team sold 500 tickets. And I usually tell the students, please understand what each number represents, okay? Before moving on to anything else, please understand the first number. The first number, it says 500. What does this 500 represent? It says tickets. So we're talking about tickets, okay? Keep that in mind. Next, each adult ticket costs $12. Again, I see another number. I'm going to highlight it because we're talking about numbers here. And what does this 12 represent? Well, it has a money sign. So it says that each adult ticket. So it means that they're talking about adult tickets. How much is each adult ticket cost? All right, moving on. And each student ticket costs 7. I see another number. I'm going to highlight it. What does this 7 represent? Is the student ticket costs. All right. Next, they made a total of 4,495. I see another number. We highlight it. Make sure you understand what this 4,495 represents. Again, it means the total. All right, write a system of equations. So we need to write equations to model this real world situation. We're not solving, we're just writing these equations, okay? So the first equation, you're going to be asking yourself, well, how do I start this? I usually tell students, if your numbers have a money sign, they belong together. So for example, 4,495, 12, and 7, they all have a money sign. So that means that we are talking about money. The first equation, and I'm going to write it right here, is talking about money. Okay. All right. The money that, the numbers I'm going to use for this equation has to be 12, 7, and 4,495. Again, we are writing equations y equals mx plus b. Okay. I told you earlier that y represents the total. So you should always write the total in one side. And the expenses, so this right here means expenses on the other side. How are you wasting your money, or how are you getting to that total, right? So I'm going to write 4,000, okay, 495 on the left, and I'm going to set it equal to the expenses. How am I making this 4,495? Well, I know I have $12, okay, and I know I'm going to be making $12 for each adult ticket. For this situation, I do not know how many adult tickets I'm gonna be selling, so therefore I'm gonna put the variable X. And again, you can put whatever letter you want, it doesn't matter. What else are you going to be using? The plus 7, because you're also making money by selling student tickets. You do not know how many student tickets you're going to sell, so that's why I'm going to put the letter S. Okay? So please make sure that if you're using letters, you label them. So I'm going to write right here X. What does X mean? Adult ticket cost. Sorry, adult tickets. And then I'm going to ask S because I use S for student ticket. I don't know how many tickets I'm going to be selling. All I know is that I'm going to be selling for 7 and the adults for 12. And I know that my total has to be 4,495. So that right there is my first equation. I am done. And I actually tell students, once you're done using those numbers, you're not going to use them no more. So you don't need them. So what do I have left? My 500. And what does that 500 mean? The total tickets that they had. So again, that's a total. I'm going to write 500. The second equation represents the tickets. It's not talking about money anymore. It just represents tickets. Okay, 500 tickets in total. Well, what kind of tickets? We have adult tickets and we have, let me change my color here. We have the adult tickets and the student tickets. Once again, we do not know how many adult and student tickets we're going to sell. However, we know that we have 500 tickets. So then there you go. Those are my two equations. These are called systems. Again, I have two equations that share the same variable for both of them. Okay, so that's question number 1. Go ahead and try question number 2. Again, put the numbers, highlight them, make sure you understand what each number represents, and set up your two equations. Okay, I'm going to try question number 3. It says you decide to go on a romantic date to Taco Bell. You buy 3 tacos and 1 burrito and you spend $8.25. So once again, I see numbers 3, 1, and $8.25. What is this right here? What is this equation talking about? About you. You're talking about you. What are you eating? 3. 3 what? 3 represents tacos, 1 represents a burrito, and the total is $8.25. So that's a total for you. Okay? Your date. So now we're talking about someone else. Your date buys 4 tacos, 3 burritos, and a total of $16. Again, 4 tacos, 3 burritos, and the total is $16. Write a system of equations that models this real-world situation. Once again, this one should be pretty clear. The first equation is going to be about you, and the second equation is going to be about your date. Okay, so how am I going to write this? Again, we have the total on one side. You had the total of $8.25. Okay, you know you bought 3 tacos. So I'm going to use T for tacos. Okay, you bought 3 tacos. However, you don't know the price of the tacos. Okay, plus 1 burrito, and I'm going to use B. You also don't know the price of the burrito. All you know is that you spent $8.25 on those 3 tacos and 1 burrito. That means that T, and I'm going to label it here, and you must label your letters. T represents tacos. B represents tacos cost, sorry. And B represents burrito cost. So T again means how much is a taco, the price of the taco. Since we don't know, all I know is that you bought 3. And the price of the burrito, we don't know, but you know you bought 1. All right, your date. Your date, the total is 16. So that's on one side. On the other side is, how are you getting to those 16? Well, your date had 4 tacos. We don't know how much is the tacos, plus 3 burritos. And again, I don't know the price of burritos. So once again, you can see that we are using the letter T for both of them for the price of tacos, and the letter B for both of them for the cost of the burritos. And we are done. You can go ahead and try number 4, and I'm going to move on to number 5. Marcos opens a new bank account. He deposits 25 that he won at a robotics competition. Here we go. I have the first number, 25. 25 is a deposit. I don't know if you guys know, but deposit means that you are putting into your account. You're going to put into your account. That's what you're starting with, okay? He also plans on depositing $10 a week. I see another number. And what is this $10 represents? The depositing of each week. Okay, so you're going to put in $10 more every week. All right, Philip decides he wants to save money as well. Okay, so now notice how we're talking about Marcus first. So let me color that, and let me switch my color here. Philip, now we're talking about Philip here. He wants to save money as well. He already has 40. That means that he is starting. The word already has means that it's starting. Okay. Save from mowing lawns over the summer. He plans to also save $10 a week. So I see another number. What does this number mean? The money that he's going to save a week, per week. Okay. Write a system of equations that models this real situation. All right. The first equation, you should be talking about Marcus. And the second equation should be talking about Philip. Okay. Notice how we only have 2 numbers. The 25 is a starting number. So again, on our equation y equals mx plus b, we have the m that represents the slope, how much is it changing, and b, which means the starting point. What we don't know for this equation is the total. You don't know the total money that Marcus is going to have after certain weeks. So instead of putting the total number, I'm just going to put y. Y equals, okay, the slope, how much you're going to be saving up every week? $10. So it's going to be 10. It's changing by $10 every week. Do you know how many weeks? No. So X represents the weeks. How much does it start with? 25. All right, let's do Philip now. Once again, you don't know how much Philip is going to save at the end. So it's a Y, we are unknown. And he is also saving $10 per week. And he's starting with $40. Once again, we need to label our X and Y. Again, Y is the total money in the savings account. And X is number of weeks, which again, we don't know how many weeks. So here we go. We are using 2 letters for both of them. Keep in mind that we keep using the same letters for both, and we're always just going to have 2 variables, no more than that. All right, and you can go ahead and try the last problem. If you ever have questions or need more practice, let me know.